Now this problem is again related to metal insoluble salt electrode. So we have been given formation constant for Cn minus and cobalt 2 plus. So this reaction, so you have cobalt 2 plus. So let us say you have cobalt 2 plus, and this reacts with 6 mole of Cn minus. So if this reacts with 6 mole of Cn minus, this will form a complex COCN whole 6. So this will form this complex COCN6 and 6Cn minus and 2 plus. So I will have this side 4 minus charge. So this means this side I have to have 4 minus charge. Now this reaction, the Kf value is given, formation constant is 10 to the power 19. Now we have to calculate what is the E degree for this cell. No, this is given. A standard reduction potential for this cell is also given. So this cell, that is COCN whole 6. So this is COCN whole 6, 3 minus and plus electron, and this goes COCN whole 6, and this is 4 minus, and E degree for this cell is given, that is 0.83 with a minus sign. So this is minus 0.83. Calculate the formation constant of this reaction, that is COCN whole 3. So we have to find formation constant for CO3 plus 6Cn minus, and this gives you COCN whole 6, and 3 minus 3 plus, so this side 6 minus 3 plus, so this side you will have 3 minus. So we have to find what is the formation constant for this reaction. Now you see how we will proceed. E degree for this reaction is given, so this means this is 1m and this is again 1m. Concentration of this is 1m, concentration of this is 1m. Now you can think this cell as basically nothing but, so if I have cell CO3 plus electron, and this gives you CO2 plus. And now E degree for this cell is given. So E degree for this cell is 1.82. So 1.82. Now you see this cell can be thought as a non-standard condition of this cell. This side also I will have CO, so this is minus. I will have CO2 plus, and this side I will have CO3 plus. So cell number 1, and let us call this as a cell number 2. So cell number 1 can be thought as a non-standard condition of cell 2. So I can write basically cell number 1. Cell 1 can be thought as non-standard condition of cell 1 or cell 2, sorry, non-standard condition of cell 2. Are you getting? So if I can somehow calculate E cell for non-standard condition, I have done. Now let us say you can think this cell, if you are if you want to see this reaction, you can basically use this two sum, and then you can get this reaction, this one and this one. You need this one, basically cell number 2, you need this one. E degree for this cell is given, and a standard condition cell E degree is given. So basically let us say how to find CO2 plus and how to find CO3 plus and non-standard condition. That is my task. Are you getting or not? So what is the concentration of CO2 plus and what is the concentration of CO3 plus at non-standard condition? Are you getting? Now my task to calculate the concentration of CO2 plus and concentration of CO3 plus at non-standard case. So this is the only two tasks we have. So how we will proceed? Now I know the E degree for this cell, and this E degree is when I have this is 1m, and I have this is also 1m. So if I know the E degree for this cell, how we will proceed? Okay, let us calculate. So what we have to do is we have to find E degree for this cell. So let us try to calculate E degree for this cell and then we will equate this E degree. Now this is 1m, so this is 1m. Now calculate the concentration of CO2 plus. So I can write this is 1 divided by Kf is equals to, so Kf is equals to 1 divided by, because this side I have 1, so this concentration is 1, CO2 plus Cn minus raised to the power 6, CO2 plus and Cn minus raised to the power 6, and Kf value is given. Kf is basically 10 to the power 19. So from here I can write this is 10 to the power 19 is equals to 1 divided by CO2 plus and this multiplied by Cn minus raised to the power 6. So this is equation number 1. Now let us say I have to calculate CO3 plus also. Again this is 1m, this is standard case. So I can write Kf divided by CO3 plus 6Cn minus. So only thing is, in place of I will have CO3 plus, in place of CO2 plus I will have CO3 plus. So this value will be, so Kf, now this time I will have Kf is equals to 1 divided by CO3 plus and Cn minus raised to the power 6. So this is equation number 2. Now you see what we will have. So this is this reaction. I can write E cell for this reaction is E degree 1.82 minus. So E cell is given, that is basically minus 0.83. Minus 0.83 I can write this is minus 0.83, that is equals to E degree. E degree is 1.82. 1.82. So this is 1.82 minus 0.0592 divided by 1 log of CO2 plus divided by CO3 plus, log of CO2 plus and divided by CO3 plus, CO2 plus divided by CO3 plus. Now CO2 plus concentration and CO3 plus concentration is already given, so we can write this value. So minus 0.83, this is equals to 1.82 minus 0.0592 divided by 1 log of CO2 plus, and that is CO2 plus is nothing but 10 to the power 19. So 1 by 10 to the power 19 into Cn minus raised to the power 6. Basically this Cn minus will cancel out. And now CO2 plus, because CO3 plus we can calculate from here. So this is 1 by Kf. So Kf will go on the top. So we will have Kf here. So this is Kf into Cn minus raised to the power 6. Cn minus raised to the power 6. Now Cn minus is in the same solution, so I can cancel it out. So now I will have, so this value is, let us say this goes this side, so 1.82 plus 0.83, this is equals to 0.0592 log of Kf divided by 10 to the power 19. Are you getting? This is easy. So now I say log of Kf divided by 10 to the power 19. This is equals to 325 and 886, 1.65 divided by 0.060592. So let us do this calculation. So 1.65 divided by 0.0592. So this value is 27.87. So this is 27.87. So this means I will have Kf value is around, Kf is, you will have 10 to the power 27.87 and multiplied by 10 to the power 19. So this means I will have Kf is equals to, you will have Kf, this is 10 to the power 27 into 10 to the power 19 into 10 to the power 0.87. So this is around 9 plus 7, 16. So 10 to the power 6 plus 1, 2, 3, 4. Are you getting out? 2, 1, 3 plus 1, 4. Yeah. Now 10 to the power 0.27, 0.87. So let us calculate this value. 10 to the power 0.87. 10 raised to the power 0.87. So this value is 0.87. So this is 7.41. So this is around 7.41. So this is 7.41. So now I can say the K value for this question is 7.41 into 10 to the power 46. So this is a K value. Now let us check this K value. So around 10 to the power 46. This is 10 to the power 63. I have done somewhere some mistake. So where is the mistake? Yeah, this mistake is here. This is 1 plus add to this will be 2.65. So this is 2.65. And now let's divide this 2.65 divided by 2.65 divided by 0.0592. So this is 44.76. So this is 44.76. So this value is 44.76. This means here I have 44.76. Are you getting? Now this is 44, no 27. So this is no 27 here. And this is also not this. So I have to change this value. So let us go fast. So I will have 44.76. So this is 10 to the power 44.76. Are you getting? So 10 to the power 19 plus 10 to the power 44.76. Let us wrap this one also. Now let us write. So I can write Kf is equals to 10 to the power 19 plus 44 into 10 raised to the power 0.76. 19 plus 44. So this value I can wrap this one also. So let us say now we will have this value is 10 to the power 19 plus 44 943 4156 10 to the power 63 into 10 to the power 0.76. So I have to see the log 10 to the power 0.76 10 raised to the power 0.76 and this value is 5.75. So now K value is 5.75 into 10 to the power 63. Are you getting? So this is my K value. So let us check. Around 8.227 10 to the power 63 is okay. So order is okay. And this is difference because of the 0.592 people are taking 0.059 and that's why this is the difference. Order is same, that is sufficient. Now this is a good problem basically. This is a very good problem because this covers the concept of concentration of CO2 plus and concentration of CO3 plus. To find how to find concentration of CO2 plus concentration of CO3 plus, for that case you have been given two equilibria. One is this equilibria, another is this equilibria, Kf equilibria. From these two equilibria I have to consider the CO2 plus and CO3 plus, and then you have to add these two here because this is a non-standard condition of this cell. So first you realize this cell number 1 is a non-standard condition of cell number 2, and then you find concentration of CO2 plus concentration of CO3 plus, E degree can equate, and then you will get the answer. So this is a quite good problem.